Started with dimensions or person said they don't understand, please pay attention. As I explain, open your book and read it too. Like I said before, you cannot totally rely on the teacher and expect a good result. You have your own work to do too. So please, as you are attending this tutorial, please make sure you also study your book personally. Any area you don't understand, tell me, sir, this aspect I don't understand, and I'll create a video especially for you. So let's talk about some things under physical quantities, fundamental quantities, derived quantities, and also dimensions. So we have already said, is this a continuation of the class we had yesterday? Okay, so I'm doing this video to solidify your understanding of this topic for those that said they still do not understand. For those that got something from the class, watch this video till the end. Make sure, I always advise you to put a jotter beside you and a pen. Make sure you are jotting, sit down as though you are in a class, all right, irrespective of whether or not you are using your phone. So many people are easily distracted because of phone, or you are using your phone. I know some of you will still receive WhatsApp message. Now you will pause this video and you go and reply to the message. At this time, you shouldn't reply to any other message. When you are learning, you are learning. When you are not learning, you know you are doing other things. Okay, so I saw some questions, Jamb questions, past questions, all right, which I will be reading. Some of them will just read them. There's some of the things we did yesterday. So number one question I have here is, which of the following is not a fundamental SI unit? Which of the following is not a fundamental SI unit? Number A, option A, they said meter. Option B, they said ampere. Option C, they said Kelvin. Option D, they said seconds. And E, radian. I will leave you to answer this question. Please answer the question. If you actually paid attention in yesterday's class, you should know the answer to this question. Answer the question and put your answer on the comment section. But the other one is, they said the international agreed system of units for physical measurements are, the international agreed system of units for physical measurements are, option A, pounds feet seconds, B, gram meter seconds, C, kilogram meter seconds. Now you see, this answer is, remember I was emphasizing on the three major fundamental quantities. This answer is from the three major fundamental quantities. If they talk about the international agreed system units, it is the internationally agreed system units. Please take note of it. You have it from kilogram meter seconds. Is it kilogram meter or meter kilogram seconds? Anyone you want to put. Just know they are the units of the three major fundamental quantities. The units of the three major fundamental quantity, which is length, mass, and time. That was where I was emphasizing on these three major, because I know questions usually come from this. So if they ask you which of the following is the internationally agreed system unit, just bring out the SI unit of each of these. That is the answer. So length, mass, and time. That is the correct answer. Length, mass, meter, kilogram, seconds. The unit of this is meter. The unit of this is kilogram. While the unit of time is seconds. That is the internationally agreed system unit. Which of the following is a fundamental unit? A, you have Newton. B, watt. C, joule. D, seconds. Which of the following is a fundamental unit? Option A, they said meter. Newton. Newton is not a fundamental unit. Newton is a derived unit. Newton, of course, is the unit of force. And force itself is mass times acceleration. So since force is mass times acceleration, it means that force itself is what? Is a derived quantity. And for it to be a derived quantity, it also means it would have a derived unit. So the unit of force, which is Newton, can never be a fundamental unit, but rather a derived unit. The unit was gotten from what? Look at this. This is your mass. Mass is in kg. This one is also acceleration has its own unit again. If you combine the unit of mass and the unit of acceleration, that gives you the unit of what? Force. This is why they call it derived unit. It's not a fundamental unit because it is derived from what? The unit of mass and the unit of acceleration, if you combine them together, that will give you what? The unit of force, which is kilogram. The unit of acceleration is meter per second, kilogram meter per second square. This is the unit of force, which is gotten from the combination of these two, the unit of this one and the unit of this one. The unit of mass is kg. The unit of acceleration is meter per second square. So if you combine them together, it gives you kilogram meter per second square. That makes it a derived unit because it's gotten from the combination of the unit of mass and the unit of acceleration. For those that say I don't understand, are you getting it now? Are you getting it now? So that is it. So this is not a fundamental. Newton is not a fundamental unit. This is what they call Newton. If you hear Newton, they are simply referring to kilogram meter per second square. So if you have solved any question, you have solved the value for force in any question at all. It's either you use Newton as your unit or you use kilogram meter per second square. They are both unit of Newton. This is what they refer to kilogram meter per second. 1 Newton is equivalent to 1 kilogram meter per second square. Take note, 1 Newton is equal to 1 kilogram meter per second square. Please take note of this. So Newton cannot be the answer. Another thing is watt. Watt. Remember, watt is the unit of power, and power is a derived quantity. What is the formula for power? In fact, any quantity that has its own formula is not a fundamental. It's not a fundamental quantity, and it also means that it cannot also have a fundamental unit. Okay, every fundamental quantity has its own fundamental unit, and every derived quantity has its own derived unit. So watt has a fundamental quantity, which is power. Power is the fundamental quantity, is the derived quantity of watt. Watt is the unit, the derived unit, is the derived unit of power. Do you understand now? So it means that power, which is the physical quantity of watt, does not have a fundamental unit. So watt cannot be the answer, because power is equals to work done over time. Please take note of this formula, so I beg you. Work done over time. Power is equals to work done over time. So my writing is kind of power equals to work done over time taken. So you can see that power is derived. Power itself is derived. How is it derived? So you have your power. Please, what is work done? Work done is force times distance. Force times distance all over time. Let me just use T. Your power is equals to what's the unit of force? Remember, we just measured the unit of force, which is kilogram meter per. Per means divide. Per second square, that is divide by second square. Times, what is this? This is distance, right? We have only brought out the unit of this. The whole of this is the unit of force alone. What about distance? Distance has its own unit, which is meter. Remember, we still have divide. Divide by, that is divide by time. Time is seconds. So you still have divide by time, which is in seconds. Unit of. Are you seeing it now? So if we combine all of this, we will now have power to be equals to kilogram. This is m times m. M times m will give you m squared. So divide by s squared times s will give you s raised to the power of 3. If you have done indices, I believe you should understand. So the unit of power is kilogram meter square per seconds cube. The unit of power is kilogram meter square per seconds cube. Kilogram meter square per seconds cube. I told you, anyway, you see this divide, you call it per. kilogram meter square per, you can write it like this, kilogram meter square per seconds cube. Or you can also write it like this, kilogram meter square per seconds cube. This is what they also call watts. Just the same way you have kilogram meter per second square as Newton. That's how this one also exists as watt. So watt is a derived unit. So watt cannot be the answer. Yes, I want to believe you are jotting. We also have another option again, which is joule. Joule. Joule is the unit of work done or energy. Energy is measured in joule. So energy itself is a derived quantity. Work done, which also has the unit joule, is also a derived quantity. So it means that joule is a derived unit, since it is the unit of energy and work done. So if work done and energy, they are both derived quantities, it means joule itself will also be what? A derived unit. And look at it, let us break this down. Energy is equal to force times distance, have you? So we have our energy. Force is what? What is the unit of force? Force is kilogram meter per seconds divided by second square times what? Distance again. Our distance is in meter, so you put m. So you have energy to be equals to, if you combine all of these, kilogram, m times m will give you m square. That is kilogram meter square per second square per second square. This is the unit of energy, which is also known as joule. So this and this are the same. 1 joule is equivalent to 1 kilogram meter square per second square. So joule is a derived quantity. It's derived from what? Mass, which is derived from kilogram, which is the unit of mass, meter, which is the unit of length, and seconds, which is the unit of time. Combine all of this, it gives you what? Your joule. So joule is a derived quantity. Look at the other option they put here. Another option. They say seconds. Of course, this is the answer. This is among all of the options. Seconds is the only fundamental unit. So this is the correct option. Seconds. I don't need to explain this way. I've done this before.